go ahead and circle that, okay? Now we're going to end up going through 4 different types of inheritance. We're only going to do 3 of them today. Go to the very last page of the packet. There's like a little thinking map on there. See the middle, the title box? Put in types of inheritance. And then label off 3 boxes or 3 of the little circle pie cutouts as 1, 2, and 3. All right, we're not going to do the 4th one today. We're not going to do the 4th one today. Now go ahead and go back to the front page. Now you've done Punnett squares. You guys have all done Punnett squares, right?
Yeah.
Okay, so this is how it was set up, and probably you've never been explained of why it comes out the way it is. I'll show you. Now the meiosis is pretty much key to understanding why we do the Punnett square, or what it all comes down to. We're going to take 2 cells. We'll say this is dad. We'll say this is mom. We're only going to use 1 set of chromosomes because we can't do all 23 pairs. So we'll say we have this pair. Put a G marker on there. We'll do another pair here. Put another same G marker on there. We'll say we'll use dark colored eyes. Okay, and this one will say, and this is the other thing, you got to get homozygous, you got to get heterozygous, you got to get homozygous recessive dominant, you got to get that down today. I don't want to hear any more big D, little d, and stuff like that. You got to get those terminologies down today. I'm going to say that this is big D, this is little d. We'll say on this side is big D, and this is little d. When you go through meiosis, though, you end up creating 4 new cells. These 2 are going to be big D, because you're going to create those 4 new cells. What are these 2 going to be? Little d, little d. This side, these first 2 are what? Big D, and then little d, little d. So this is basically how it's set up. And then this guy Punnett basically set these squares because he said, here's where it goes in long format. The other thing on here, I think it said, this is a crazy one. 77% of students can determine the probability using a Punnett square. So 77% of you guys will be able to hammer out a Punnett square easily. But only 66%, so that means almost a third of you guys, understand that this is a probability that's predicted. It's not a certain outcome. All right, so I'll say, what's the predicted outcome? What's the probability? It doesn't mean that's exactly what's going to happen. It's a probability. But he said, based on these alleles, here's the probabilities. If I took, here, watch. Since this is dad, I'll make these into little sperms. Okay, those are my little sperms. If I took this sperm and I put it with this egg, what would be the genotype of the kid? Big D, big D. Homozygous dominant. Heterozygous.
Hey,
yeah.
Mr. Heterozygous here.
Oh, wow. Heterozygous. Okay, now what if I took this sperm and I put it with this egg? Big D again. What about this one? Okay, well what about this one with this one, and 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 all the possible combinations of crosses that you'd have in this? He goes, look, you really only have a couple different possibilities, and once you do Punnett squares enough, you'll realize that there's only really 4 possible crosses you can have. He says, we don't need to go through all this and determine the probabilities, okay? Why don't we just do it like this? On the crosses that you'll have too, some of them will have the box set up for you, some of them won't. If they don't have the box set up in there, create the little Punnett square box and make the Punnett square, okay? He said, if we only have the possibility of a number of different alleles, let's do it like this. It's all going to end up coming out as a ratio anyways. Usually put mom's genotype on the top. So mom was big D, little d. Dad was big D, little d. When you cross, if you were to cross these 2 alleles together, what would the genotype be? Be homozygous dominant. What about this one with this one? Big D, little d. What about this one with this one? Exactly. Okay, and then you have the last one, homozygous recessive. All right. So he said because you only have 4 possibilities on there, that's your 100%. You can break these down into ratios. This is your toughest part because that's easy. Your toughest part is doing this. You have to put it down in terms of genotypic ratios, phenotypic ratios, genotypic percentages, and genotypic percentages. Okay. So watch. Genotypic percentage because we're talking about genotypes. You always start with the homozygous dominant, go to the heterozygote, and then go to homozygous recessive. So I'm going to say, how many big D's do we have? One. So we're going to do one big D, put a little colon there. How many heterozygotes? Two. To how many homozygous recessive? One. Now, even if you don't have it when you do your cross, and we'll say that you have none of these, and this happens to be 4, you would be 0, 4, 0. You still want to put the zeros in there, okay? So we'll put in the 1, 2, 1. It says genotype. We're going to stay with genotypic percentage. What percentage of homozygous dominant do we have? 25% to quarters. You only have 4 here. So you have 25% homozygous dominant to what percentage of heterozygotes? 50% heterozygous to 25% homozygous recessive. Now, my phenotypic ratio is where it changes up a little bit more. So when I ask you guys a question on this, for a while, I'm going to ask you, hang on, this is genotypic ratio, sorry. This is phenotypic ratio. If this is for dark eyes, how many children will be born with dark eyes? Out of the 4, how many? 3. 3 dark because of the dominant allele in the recessive, the dominant mass, the recessive in the heterozygous form. So 3 dark to 1 light. So my phenotypic percentage is going to be what? 75% dark and 25% light. Alright? For the first set of crosses, for a little while, I'm going to require that you write all these out. Okay? Always put the heterozygote in the middle. If you have zeros, make sure you include the zeros. The other thing I saw that people made a mistake on too was the difference between capital C here and that capital C, because they got screwed up on the crosses. And I said, make sure you put the lines in there, otherwise you're going to screw yourself up. Okay? So look at your first cross. Go to your first cross, normal dominant. Bless you. I want you to finish the first page with your partner. Make sure you're working with your partner. When you get done with the first page, have him check it off. And some of you guys will figure it out. There's a trick. Watch. You can only do so many crosses. There's only really 4 crosses I can give you. And I can look at yours because I've been doing this long enough. And you guys can pick it up too. I can look at it and then go just by the parents. I can figure out what your ratio is going to be all along. You'll get a little tired of the crosses too. You're like, we've already done this one. I've already done this over and over again. Practice for a little while. I will not waste your time, but I want to make sure that you get enough practice where it becomes kind of rote and you can do it over and over again. When I ask you the answers at the end too, I'm going to ask you, what do you got? I don't want to hear big D, little d. I want to hear homozygous recessive, homozygous dominant, and so forth. Okay? Questions? Stay classy. Okay, this is what we have.